Hello, everyone. My name is Darla Saunders, and on behalf of the Atlantic Salmon Conservation Foundation, I'd like to welcome you to today's webinar. This series is made possible in part thanks to the contributions of the Government of Canada. For today's webinar, we're very pleased to be hosting Myron King. Myron is a Research Assistant 2 at the Environmental Policy Institute at the Grenville campus of Memorial University of Newfoundland. He has led geospatial data analysis and mapping efforts for several key environmental research projects. Completing the Masters of Science in Coastal Zone Management at the University of Ulster, his thesis research concentrated on the ecological knowledge of Newfoundland and Labrador fishers, highlighting their expertise in fishing and mental mapping. Recent project work includes examining Newfoundland wetlands slated for development, food security analysis for a remote island, as well as global climate change and associated potential impacts on boreal region agriculture. Myron is currently pursuing his PhD in fisheries at Hull International Fisheries Institute at the University of Hull in the United Kingdom. He's studying fish passage barrier networks and cumulative effects of hydro dams on riparian ecosystems, and particularly the impact upon Atlantic salmon river migration capability, work which has been funded in part by the Atlantic Salmon Conservation Foundation. So after this afternoon's presentation, we'll be opening up the floor for a question and answer session. Everyone will have the option of asking questions directly using your microphone, or you can type them in and we'll read them aloud. So I'll now turn the webinar over to Myron.
Thank you, Darla, and good morning, good afternoon, and good evening to the folks online, wherever your location is. My name is Myron, and I'm going to talk to you today about my project and something very important and near and dear to my heart, the impacts of barriers on Atlantic salmon. And so first, I'm going to talk about barriers and what kind of impacts they are. Some of you will be familiar with this, of course. Some of you may not know all the complete impacts there are, but then I'll go into what our collaborative approach was for dealing with a tool and framework that we designed to deal with the issue. And then I'll talk about a couple of case studies that we've applied this to and work with in live workshop environments, and then we'll open up for questions. So let's dig right in. What are barriers? So stream barriers, they come about from natural river impedances built over time. They're in our built environment, of course, including bridges or other crossings in disrepair, culverts that are not engineered properly and broken down over time. They're happening from washed out roads, and that's the case right now, happening just as we speak with some of the hurricane activity that's going on. And they happen because of hydro dams and other installations as well, and just simple storm damage from climate change impacts do the same thing. So barriers, and the barriers are very bad for salmon migration, and they're very impacting. And we've seen that over a number of years in our studies and reviews of barriers. Where are they located? So barriers can be found almost anywhere on a stream. They're often found on highway crossings, road crossings, right across your driveway, and in other forestry roads and access roads. So trailways and railway crossings, it seems there's no limit to where you can find a barrier if humans have been there and tried to create a crossing. So you'll get an idea of what I'm going to start digging into. If you got crossings as the root cause of some of these barriers, there may be ways to do mapping in GIS to find them, right? Now, those kind of things are what we call potential barriers. When you find them on a map, they're called potential barriers because you create a point where the crossing is. And the key points are where the rivers are crossed by human roads and trails and forestry access roads, but they may not be exactly barriers, right? So they're potential barriers. And in the island of Newfoundland alone, which is my province where I'm living right now and located, we have approximately greater than 17,000 of these points of river crossings. And these are rivers that are used by salmon to travel up in their spawning activity, of course, and the barriers, if they're causing trouble to the salmon, are halting or stopping that activity. And that's an important issue that we've wanted to deal with for many, many years. The potential barrier impacts. There are major impacts to salmon migration, including available spawning grounds. They reduce non-migrating fish populations. They increase damage due to the effects of climate change, which is a big part of my study. And they reduce or halt the water flow in some conditions as well. And in some cases, we've seen barriers also cause quite a bit of erosion. And in the island of Newfoundland alone, as I said, greater than 17,000 is a lot of barriers to consider. Now, we'd like to think that we're doing a really great job in restoring these. We have restorative goals for these barriers. We put a lot of money towards restoring them from year to year, and we're doing a pretty good job in certain aspects of restoring barriers. But usually, what we've found is the barrier restoration decisions have been based heavily on random visual reviews. You know, going out, and this is important, don't get me wrong, going out to see the impact of a barrier so that you know exactly what's going on and fix it. It has its good result, but
Myron, are you there?
sorry, I think I lost my microphone. Can you hear me okay?
Yes, you're back now. Thank you.
All right, sorry about that. So I'll continue. Often the barrier restoration decisions are based heavily on random visual review and maybe sometimes socio-political motivations as well. And while that happens to be working sometimes and in some arenas to be a good thing, it doesn't really effectively deal with the barrier problems in the larger picture. So if you look at the little diagram I drew here, there's a lot of barriers, a lot of potential barriers causing trouble. There's a lot of them that needs restorative attention. You know, they need the money thrown at them. They need to be restored in order for salmon migration to occur properly. And in the big circle, the big blue circle, showing that we're only dealing with a small number of these, added a big picture year to year. The result of that, many barriers remain with high impact to salmon populations, ecosystem function, and our own well-being. I mean, the reduction in salmon health and numbers is a big problem. The risk of flooding and erosion affects humans in ways of higher environmental cost, high economical costs. And, you know, when we're only paying attention and fixing a certain small number of barriers, when we know there's a lot of trouble going on with many more, it makes us turn to our management and have lower confidence in them and get upset with them. And really, you know, they're doing their best, I think, with the money that they have, and there's only a certain amount of money to deal with it. So, you know, in our management decisions, I think the aim we need is to be able to make better management decisions by arming them with better tools in order to do that job. So the tool that we want is a tool that, you know, is a good assessment and model and framework tool that'll take into account cumulative effects and prioritization of the ecosystem function, right? And in the long term, that can help highlight highly impacted areas. You know, we need the tool that can identify top impacting barriers. It'll show where the greatest increase in ecosystem health, particularly for salmon, would be realized, and provide a starting point for those managers and decision makers who are tasked with taking care of these problems with effective solutions, you know, to make sure that we're getting the best bang for our buck, as people would say. Now, over the years, some good studies already exist and have been successful in helping to show the major problem of stream barriers. Right? So, you know, there's been several studies with excellent output and outcomes to help move along dealing with the problem of barriers on rivers and its effects on Atlantic salmon. But the nature of this issue is that it's a very complex issue. And the studies are often limited by their data considerations, the availability of data, for instance. It's complicated by the political picture. You know, some rivers, if they're close to a very important election space, maybe that's caused a bit of a lean towards it. Who knows? There's scalability. You know, you need the ability to look at the small picture and the big picture almost at the same time, and the dynamics of the condition are very important. So in the past, this has limited the usefulness of various studies, especially if it didn't match the economic and jurisdictional responsibilities of our of the people that we've tasked with taking care of things here. So my project, working with my supervisors in the University of Hull and the University of New Brunswick, was to develop a geospatial data inventory of parameters describing the nature and impact of in-stream barriers. And for this first project goal, I'll mention that our limitation for that database of parameters was currently the island of Newfoundland, but in other instances, for the other case studies, took into account the data inventory that's in place as well. We also wanted to demonstrate current cumulative ecological impacts of climate change and other interacting stressors. One thing I've done a lot of work in the past few years is climate change, and I plan to use that very directly and purposefully with my study on the assessment of in-stream barriers. And we want to create an assessment and decision-making framework tool centered on scale-friendly GIS processing. And with a background in GIS, I understand, and my supervisors particularly understand, the importance of GIS processing to aim for an effective utilization of things by those tasked to deal with the problem of in-stream barriers. So in retrospect of this, our collaborative team developed the RRPAT tool. It's a river restoration planning and analysis tool for managing rivers based on the geodesign principle. Geodesign principles from Steinitz in 2012, if you wanted to take an opportunity to look at that paper up. It's a policy framework providing a structured approach for river rehabilitation of multiple spatial and temporal scales. So it takes the geodesign principle from Steinitz. It also takes the structured decision-making approach from Gregory and his team in 2012 as well. And we married these two for the idea of river restoration and planning analysis to make sure we're doing our best guided decision-making for river restoration. And this is a restoration approach providing guidance through integrated design and decision-making. It visualizes social, ecological, and spatial temporal dimensions in restoration decisions, which is very important in the political arena and when you got multiple things that people want their money spent on these days. Finally, it's a tool useful to case studies. And two of our case studies are proof of this. And we've done one case study and moving along with another already. One in the UK on the River Trent. And we're also doing a case study right here on the island of Newfoundland. Excuse me. So as I said, the RRPAT tool, it's an applied tool, and it's an applied action tool bringing analysis and situational understanding directly and clearly to the decision makers. You know, this tool we've designed is very structured and meant to be an interactive tool to ultimately work in a live workshop environment, right? And in order for that to work, the idea is to gather the people necessary in a live workshop and review very clearly and very thoroughly all the needs of the single restoration decision that needs to be made, but also the bigger picture and how it fits in the bigger picture. So through the use of scalability, through the support of GIS and geospatial analysis, we take into account quite a lot of things at the beginning before, you know, putting boots on the ground. So we've developed this tool, and you know, publication we got there coming soon. I want you to read that when it comes out. It's going to be very, very thorough in how we want to be able to use this tool for our restoration decisions, and it forms the basis, our jumping point, if you will, for tackling this problem of in-stream barriers and how we want to do assessments both on this island of Newfoundland and in the wider need around the world of assessing barriers for restorative decisions by our managers and stakeholders. As I mentioned, we have 2 case studies that I was involved with for our project here. One is the examination and assessment of potential barriers on scheduled salmon rivers coast to coast on the island of Newfoundland, which is where I'm located. And that assessment and that work is ongoing right now, and I'm continuing to do it. And the analysis at the watershed level for the Trent River system in the United Kingdom. So we looked at cumulative effects of hydro dams acting as barrier installations, and you know, these are a couple of case studies that have 2 very important locations for the Atlantic salmon species, and both have different sets of challenges that are, you know, related to not just geography, but also what has been historically the changes made already by humans in those locations. So let's get into the 2 case studies just a little bit here. The Newfoundland case study has dozens of watersheds containing many classified salmon rivers across the island. It has limited data available for many of the potential barriers in terms of ecosystem, you know, barrier type, barrier itself, and environmental factors. And as the map showed earlier in my presentation, there are quite a lot of potential barriers just based on crossings alone. And it was our jumping point for tackling this problem in the location Newfoundland. And you look at this, yet the limited management resources means we're not going to be able to fix everything in one big shot automatically. We have increased areas of responsibility, increased call for action and response timeliness, and some of these factors affect, you know, what we can do on a year-to-year basis, what the perception of what we do actually is, and we want to make sure that we're spending our money wisely and we're getting, as I said earlier, the biggest bang for our buck in terms of restorative salmon rivers on those barriers. So the step 1 was for us to develop a geospatial data inventory, and we've done that successfully with quite a database full of content developed using specialized GIS tooling. It's simple but effective for large-scale approach assessment. And what we're aiming to do with this is to create an assessment model that once we run a live workshop that we have planned for this case study, we're going to be able to at least direct stakeholders and managers, you know, along a path that will help them make better decisions of river restoration for barriers that are high impacting without involving too much of the other factors that often are related to those decisions. You know. The Newfoundland case study is a daunting number of potential barriers, and even just looking at some of the red dots show these are actually dots. It's not smudges on the screen you're looking at. Each one of these is one little dot, which is a barrier or a potential barrier, sorry, to salmon migration up that river towards good spawning grounds. Now, our case study in the UK is a little different. So the difference with the UK case study is there's actually more information available for the potential barriers in the UK. They've been studied quite more directly than the ones in at least the island of Newfoundland. And we have more information on the hydro dams, ecosystem, and salmon passage numbers that are going on in the UK. That doesn't mean we're doing a terrible job in Newfoundland. It just means that more studies have gone into doing monitoring and measuring on these rivers in the UK. The result is that they have a lot more data, so you have a lot more complexity to swim through in order to help the managers make the better decisions in the UK. The impedance for salmon populations to swim up those rivers is still very evident, and the impacts are increasing cumulatively up each river with each barrier that has to be passed. So managers, they end up struggling between salmon-friendly practices and actions versus highly desired and increasingly needed clean energy sources that they get from hydro dams in the UK. You know, it's a catch-22 where you're looking to get better energy for human use, but you're affecting one of the major routes or major Atlantic salmon spawning areas that are maybe on that river. So the managers need to be armed with the right tool to make the right decisions in those types of cases. Here's just a picture of the UK case study, the hydropower installation, the center of human development to give us the energy we need, but all these characteristics of how it might affect another species, the Atlantic salmon, for using that river. You know, you have altered sediment dynamics, altered flow regime. The flow requirements might change based on the hydropower installation. Even the structure itself might suck in some of the fish into in the turbine and get them in trouble. And you know, there's a lot of different studies and a lot of different approaches that have attempted to assist Atlantic salmon, and they've done pretty good in making sure that the majority, perhaps, of the Atlantic salmon they're trying to protect. But when you have so many going on in so many installations, and it's so many cumulative sources for migration disruption, then overall the problem is still existing and still needs addressing. In the UK, we have typical hydro dam installations in up along the river every few kilometers. Here's a few in Beeston and Derwent, and I must say I've looked at the various installation point sources around the UK, and there's quite a lot. This is just a picture of some of them. There's one in Cromwell. These are some of the ones forming some of the case study that we're looking at directly in terms of developing our tool and making it work for multiple areas, but the problem is very, very deep. The key to the UK is the hydro dam concentration. The cumulative effects need to be incorporated without endangering the simplicity of the framework model. That's the RRPAT tool. And the recognition of the human energy need still has to be taken into account. We need energy, and we need to make sure we're getting our energy despite our best efforts to protect the Atlantic salmon as well. So again, for this case study, we'll be doing live workshops. That allows us to run through the dynamic of the RRPAT tool to point management in the best direction for targeting where their decisions on restoring in-stream barriers need to be made or could be made to have the biggest bang for the buck. The thing about the UK is there's more details about the potential barriers available, but that causes an increased complexity. So the picture is a little more difficult for management sometimes in those decision-making steps as well. So we wanted the tool to be able to both address an area that had little data available, such as the island of Newfoundland, which has some, but is not very much. Excuse me. But we also wanted to be able to work in a place like the Trent River for the UK, where there is a lot of data available. Finally, I'll turn to the other segment of my project is to look at the climate change wrench, I'll call it, that's going to be thrown into the picture, and already is thrown into the picture for affecting Atlantic salmon in terms of barriers and barrier installations around the world. The impacts due to climate change must be considered as well, despite our anxiety over scenario estimation. So, you know, even with pictures of climate change that are coming out, it's throwing a wrench into it in a way that complicates it to a degree where it's going to be very hard to make decisions. And the climate change the climate change picture creates many alternative scenarios of the future, which will make the decision even harder than it would be just looking at political aspects or greatest areas to have a turnaround of a good result for the Atlantic salmon. But on the bigger picture, if we take climate change into effect now and we continue to do it, when climate change starts to really make deep, significant impacts on us, we'll get used to making these decisions, you know, ahead of time. And hopefully some of the restorative decisions can be made long ahead of the real impact climate change will have, and help us make the decisions we need to right now. Climate change is going to have environmental variability. Storms and damage will increase to infrastructure, higher economic costs, and this creates all the pressures on decision makers now, and will continue to put pressure on them in the years to come. We've heard this story over and over about climate change, and I just finished with another team doing a study about climate change globally on agriculture, and it is going to be quite a doozy to impact not just humans, but our installations and therefore the Atlantic salmon directly as well. So we need to take into account for our scenario forecasting and include it for river restoration decision making, so that our decisions in the future will be still effective decisions for restoration. Downscale general circulation models can help provide future temperature and precipitation guidance at regional levels. So I've been involved with studies that are already using downscaled climate change modeling, which will help me to examine with my collaborative team and supervisors the local impacts of climate change on even as scaled areas as local single rivers. So that's going to be a very important effect, a very important consideration for management to look at when they're trying to determine where to spend money and when to spend it for restoration. We're going to make climate change scenarios. Their assessments will be supported under our RRPAT tool for use in management decisions. And I think that's just an outcome that we expected to occur when we're developing a tool that we want to have people use for making better restoration decisions, would be to include the big wrench of climate change that's coming down the pipes toward us, and happening right now as we see around Canada and the rest of the world. So I'd like to take this opportunity to thank my project partners and sponsorship, especially the Atlantic Salmon Conservation Foundation, and also for allowing me to speak to you today directly through this webinar. Thank you very much.
Thank you so much, Myron. So we'll now open up for a question and answer session. So folks have a couple of options for asking a question. You can use the webinar control panel, which is the little gray box you should be seeing in the upper right-hand corner of your screen. And you can click on the icon to raise your hand, and I can unmute your microphone and you can ask your question to Myron directly. Or you also have the option of typing in your question right into the control panel, and I'll read it aloud for you. So we'll give folks a few minutes. And I'll mention as well, for those of you who have colleagues who perhaps weren't able to participate today, as you'll have seen from the note that I sent out, this was a very popular webinar and we significantly exceeded what our capacity is. But we have recorded the presentation and it will be available shortly on our YouTube channel. Okay, so we have the first question from, oh,
Go ahead.
sorry.
Go ahead, sorry.
Oh, I was just going to say we've got our first question here from Kevin Gallant, who says, we are doing a lot of shoreline restoration to promote ecosystems. Have you studied the types of shoreline plants to help with erosion and climate change, readiness for rainfall events, etc.?
I haven't looked directly at the shorelines for climate change impacts and erosion. I know it occurs at the shorelines, down at the mouths of rivers and salmon rivers especially. So we're cognizant that that is occurring, yes. Mainly our project is targeting the in-stream barriers. So it would start with the very first barrier that occurs when traveling up from the shoreline and go from there. So you might hit the first one, 500 yards or 1 kilometer, 1 mile into the river. And then cumulatively, you're having additional barriers, one after another, affecting the migration of salmon up through the river in order to spawn. So that is the target of this project and was the target as well for the tool that we created, Crossing Geodesign with Structured Decision Making. I am a coastal zone management enthusiast. I did a master's degree in that. So I would invite Kevin to open a dialogue with me and talk about it, perhaps through emailing to see what more is going on with that.
Great, thank you. Kevin has a follow-up question saying Scotland has over 500 micro hydro sites and a lot of them are in-stream dams. Which types are more in-stream friendly?
I think the friendly ones are the ones that impede the river the least amount, and that sounds intuitive, but it's not quite always intuitive because it sometimes depends on what the river flow is, what the current water flow is, as well as how out of the way you make any fish swim in order to get around it. And the big picture that I'm finding in studying this is that it usually doesn't depend on, okay, you run into one hydro dam and that seems to be a big problem, and then that's it. Like you were mentioning, the real culprit here for migration of salmon is when they occur one after another, one, continuous up a river, so that the depletion of that natural pathway is so degraded that by the time you get to the last salmon, there's no salmon. By the time you get the last installation, there's no salmon left going up that river. And we see that time and time again. I don't know 100% which are the most offending designs within the hydro dam installation area. I'd encourage the listener to go and check out some of the technicalities for which diverts river volumes without replacing them, or how they impact flow regimes especially. And I think that's where I'd have a starting point in order to determine that. Our main direction for including hydro dams is to account for passability of salmon through these structures, as usually is rated by salmon counting processes or directly by the installers themselves, who would have gone through a design process to show what is passable in terms of theoretical numbers. So, these are across the board and usually have a range of values. And for Scotland, there must be some perhaps background information available that way as well.
Okay, thank you. We have a question here from Frank Johnson. Frank, I'm going to unmute your microphone. I think Frank needs to unmute his own microphone as well. So maybe I'll just give him a minute to do that and I'll follow up with some of the other questions. Anton Richard asks, is the RPAT available? Is it an ARC map-based tool?
Initially, and it definitely incorporates ArcMap tool analysis things as well as non-ArcMap GIS activities. So is not technically centered on ArcMap. We didn't want to put ourselves in a box where we weren't sure what the continued support model might be for a tool like that. And our tool is mainly a framework and tool design that makes use of these GIS tools, but doesn't stick you down to one in particular in order to for continued maintenance and usage as the future rolls on. So the short answer to the question is that is not an ArcMap based tool. It is more of a policy and framework modeling tool that'll continue to be used as a policy tool and research based SDM process and geodesign marriage as we go on trying to make restorative decisions in the future. I'll mention that to watch for that publication would be a great idea, and you'll learn about the tool and its approach. We've submitted that now to the Journal of Environmental Planning Management, Environmental Planning and Management, and hopefully within a short amount of time that'll be out for good review and read.
Thank you. Frank Johnson, I think we now have his microphone. Frank? Frank, are you able to ask your question? Okay, still nothing there. So we seem to be having some technical problems. Frank, maybe if you could type in your question. Our next question comes from Gerald Chaput, who asks, hi, the focus appears to be Atlantic salmon. How does biological characteristics of the species play into the development of scenarios? For example, fish size, swimming abilities related to temperature, slope, and are downstream passage considerations included?
That's an interesting question. Thank you for that. We're approaching the tool and the development of the tool from not just Atlantic salmon species, actually. So even when we've done a run of this tool in case study mode, testing it, we use 3 different species then to accumulate some of the data for our testing and ongoing changes to the tool and how we develop it. We believe the tool will help with direct restoration of in-stream barriers towards not just Atlantic salmon, but other species as well. And what it'll take into account may depend, yes, on the physiological and biological aspects of species that are in question, including stuff as the reader or the listener had said, like the slope that is going on for the culvert in practice. And, just as a reflection, there are different fish species that have different burst speeds in order to get across or get up a certain amount of height through perhaps a culvert or a small riser. And that can be taken into account towards a policy framework and design tool when the knowledge is known and data is incorporated. So yes, it means that in the beginning of our tool, there's some more footwork to prepare and provide the decision-making team, the stakeholders with that information and research ahead of time. And that perhaps is one of the strengths of the tool, is that you do that work to provide enough information that better decisions can be made based on the species in question as well.
Thank you. The next question comes from Dirk Algera. Can you speculate on the challenges and applicability of using this tool for other species such as European American eel?
Yeah, so I'll elaborate on what I was just saying. We've tested it based on river lamprey and eel, as well as Atlantic salmon in our first run that is a part of the submitted article that is coming out in the Journal of Environmental Planning and Management. And in there, we did it for eel, and river lamprey additionally. And what is taken into account here is what the expert's knowledge of these species is and how it relates to the environment and what's going on around those particular barriers or cumulative set of barriers. And that has to be done. It's almost like doing a bit of homework ahead of the live workshop so that you understand what you're going in with and what you need to bring to the table to understand both the barriers and that one river and how it relates to the bigger picture as well. And so I think that makes the tool more accessible and more a broader design development that'll work for multiple species rather than just the Atlantic salmon. Although our key species we were aiming for this to really crunch and be effective with was the Atlantic salmon at this time.
Thank you. The next question comes from Sarah Tuziak, who asks, are aquatic invasive species presence and movement being taken into consideration in your model?
The model is actually a framework with policy in place, which means whatever you bring to the model is what is considered. And this, it sounds intuitive at first, but it's not quite. So there's complexities involved where, depending on the situation, you may need to bring different sets of data to a tool, to the question, in order for that to remain a part of what the decision makers need to consider when making the best decisions possible. And the idea through the adoption of geodesign, as well as, and not to leave it out, structured decision-making process, is that you're implementing a tool that both takes into account the GIS and the spatial aspects of the surrounding geography and the barrier positioning and implements themselves, but also what is important in terms of socio-political activities, environmental aspects, human installations, and other human installation or human habitation that's going on around a river as well. So there's actually enough space and guidance in the tool to bring that to the picture for a live group, a live workshop of experts to consider in order to help direct the management team and this decision-making team towards better goals. I hope that helps answer the question.
Thank you. The next question comes from Colin Murray, who says, "Thank you for the informative presentation. It seems on the visual that there is a lot of barriers on the GMP. Is there anticipation of a further increase in the impacts of in-stream barriers and climate change with the planned increasing forestry in the future on rivers on the Northern Peninsula?"
So when we were looking at the development point for our database and how to populate the barrier, the number of barriers we had, we took into account all forestry management roads that we could think of and find, all trails and all highways and roads and driveways, every crossing we could consider. And that also takes into account, things where we've gone into the forest in the past, developed roads, and in some instances forgot about those roads that have now grown over but have maybe 2 or 3 pipes underground, still causing trouble for the migration or the passage, even just the passage of water in some cases through that area. So when we took that into account, we believe that this type of tool and the background data that's necessary to collect for implementing the framework and tool really needs to take into consideration experts from forestry and their management as well. And part of our idea for doing this under live workshop conditions is to get feedback immediately and proactively and immediately within the live workshop to help determine decisions going forward in areas where forestry management is of high importance. So the live workshop might include important stakeholders like forestry management decision makers, and that brings into the picture the kind of things that are necessary in order to make decisions with more of the knowledge that's needed for the best decision to be made. I don't know if that answers the question directly, but when there's more forestry going on, the best way, we're going to be cutting forest, and they have certain management plans that allow them to be sustainable, and they've gotten a lot better at crossing rivers and making sure that rivers are not left unattended when they go into new areas. Having them involved as stakeholders and decision makers in restorative decisions will only strengthen our process and the live workshop environment rather than hurt it. So I think that's where we're going.
Thank you. The next question or comment comes from Colin Bull, who writes, interesting talk. I'm interested to hear how the issue of partially passable obstacles to Atlantic salmon is being treated in the tool. Size or time. Selective obstacles may have variable impacts on upstream population abundance and also structure if passage allowed for some size of fish or run timing.
Yeah, so what you're getting into is, within a GIS world, there are certain direct tooling capabilities that will allow you to really get in, crunch some numbers and determine almost scientifically to an accuracy of X degrees what is passable and what is not. But in reality, we're still coming down to, basically just estimates of passability, sometimes estimates of habitat that's freed up in terms of passability. And it's hard even to take into account the amount of water that's flowing one time or another. So we've attempted in this case to be as simple as we can, to approach it with simplified parameters, not to really make the decisions and show, okay, here's your number one, your number two barriers that you need to go fix. That is not what we're attempting to do here. Our attempt is to bring in the bigger picture so that all the barriers can be seen. There is maybe a prioritization and recommendation of which ones are the most offending, and that'll be based on some of the most simplified criteria, such as in some cases maybe as simple as slope that is indictment of the barrier going through that area. Other things might be temperature and precipitation related for ideas around climate change activity. So the real key to our tool was to aid decision makers and stakeholders in the live workshop environment towards making the decisions they need to make based on not just the scientific data evidence that's going on in the place, but also to take into account other environmental variables, social, political, and social economical states of the situation, which really is what most decisions end up being made with without some of the geodesign aids that are often needed.